Welcome back to the Hypergeometrical Universe series. As you know by now, I created a series of everything where the universe is a like any hyperspherical hypersurface. I learned how to model the universe by cutting it, chopping it in pieces, and getting the cross section. So here you can see the circle which represents the place where we live, 3D hypersurface that is expanding at speed of light. You can see also the proper reference frames, x tau, x tau, x prime, tau prime, and xr and x prime, r prime, and xr and xr prime, or x prime, r prime is where we really live. We don't live in space-time, we live in space. I need to tell you that space-time is just concept in the sense that it's just a proxy of what happens, nothing, not reality. And I showed you already that Einstein was wrong about everything he ever said, about time dilation, about space-time, about the twin paradox, and about Einstein's equations. And here you can see that LEHU, light speed expanding hyperspherical universe topology, is consistent as Minkowski's spacetime as a local homology, which means if you look very close, the circles become straight lines, linear segments, and those linear segments represent hyperplanes, which are traveling parallel at the speed of light in one direction. And that's exactly what Minkowski's spacetime is. I told you, but I guess I didn't emphasize properly that there is a very basic error in relativity which has to do with time dilation. Time dilation is a loose state in the sense that time is always defined in terms of process. Everything that we know about time is because we know about process. We know that day and night, or night follow today, and seasons follow each other, and because of that we can tell that time is passing. We know that we sleep, we eat, and so on and so forth, and that tells us something about time. We know atomic clocks, we know about major frequencies, and so on and so forth. And so everything that we know about time always has to do with the processes that we are time. In other words, there is no independent measure of time. Time doesn't flow. Einstein didn't have an underlying process that was under everything in the universe. The hypergeometric universe theory has. The hypergeometric universe theory has a model of matter in which particles are polymers of a monomeric unit called the fundamental dilator. The fundamental dilator is a coherence between stationary states of deformation of space. It's a solitron process which means energy has no place to go. There are only three states, and these three states have the simplest possible states: electron and proton. Everything in the universe decays into electrons and protons. Doesn't matter what it is. There is, of course, also neutrinos, which is part of my model, but this is slightly more complex than it, that has a different frequency. That explains why neutrinos are ghostly particles. They have a Fourier interaction with other particles, by which I mean sometimes the particle gets attracted, sometimes the particle gets repelled, and the end result interaction, the net interaction only happens if the particle is very close, because the interparticle potential is still Coulombic. You just have different frequencies. So the hypergeometric universe theory has an underlying process, which is the tunneling between states in the fundamental dilator coherence. What happens is that that tunneling generates metric waves, which I call a dilaton field, just metric waves. And their frequency is around 10 to the 24 hertz. So it's very, very high frequency, which means that the period is very, very short, 10 to the minus 24. The wavelength is a femtometer, 1.32 femtometers, or the Compton wavelength of a hydrogen atom. So I have a very well defined process, which is used to time the universe. Or conversely, the passage of time is defined by this process. In my theory, the universe expands through steps, which I call de Broglie steps, in homage to de Broglie, which was the original person who creates the idea of matter waves, as opposed to Compton, which is just a limit in which the matter waves are traveling at speed of light. So I call de Broglie, but I really use Compton wavelengths to measure the wavelengths of the metric waves, which are created by the tunneling of the dilaton, or the tunneling of the fundamental dilator. So as you can see here, time dilation changes the timing between tunneling. You go from one state to another, and here we have eight states sequence. So you start from electron, you go to antiproton, or then you go to anti-electron, and then you go to proton, and you go to electron, and so on and so forth. As the phases rotates in 4 dimensions. Some of the times the phases are perpendicular to our 3D universe, and that means that on those times they have zero cross-section, which means that they don't interact. This is quantization, time quantization, but it's not any kind of time, it's absolute time quantization, which means that if you are moving, you are not going to see the same quantization as another person that's moving in another direction at different velocity. So it's not time quantization in the standard sense. It's absolute time quantization. So, but the point of this figure is that the tunneling happens. There is a period which is being dilated, but the wavelength is also being dilated, and this allows the fundamental dilator to keeping pace with the universe, which is moving at speed of light perpendicular to the prior hyperplane. So, which means that matter tunnels, there's an underlying process, and the time dilation is not a loose time dilation. It's a time dilation which is dilating a physical process. And so that's where Einstein went wrong. And that's why you have these horrendous explanations about what happens when you fall into a black hole. According to Neil deGrasse-Tyson and Brian Cox, my idols, you fall into a black hole and you never fall because your time dilates, and because of that, you are going to see the end of the universe before you die. And that's such a stupid idea. And that's why. But the reason for that is because these people don't think well. They don't know how to think, and they miss the point that time is not an abstract, it's not a flow, and it's always defined in terms of a process. And Einstein didn't have any process to assign the dilation to. And I have another nail in the coffin of relativity. So this video explains why we live in a 3-dimension universe. We look every place, and you can only move in 3 dimensions no matter what. But I claim that we live in 4 dimensions. How can that be? What gives? What gives is explained in this figure. Here you see surfers. They are very small, and those surfers are surfing a circular pond wave, and they are being dragged by that pond wave. Well, if you're being dragged by the pond wave, you cannot move radially. You lost that degree of freedom. You have no way to get out from the wave. You cannot go ahead of the wave. You can only go tangentially. So you live in a 1-dimensional universe if you are a surfer. But the pond itself, you can see that it's a 2-dimensional surface. I call this dimensionality reduction by dynamic reference frame. If you use your brain, you can think about a 4D metric wave where all particles in your body are surfing that 4D metric wave. All those particles will be like the surfers on the pond. They will not be able to move along the 4th dimension, and they will fool themselves thinking that they are traveling, they live in a 3D universe when they actually live in a 4D universe. So this is the main lesson of this video. I mentioned that universe is a light speed expanding hypersphere. I mentioned that we are surfing the inner dilation layer. The inner dilation layer is a remnant of the initial hyperspherical metric fluctuation. And a metric fluctuation is something that's dictated by the Heisenberg principle. If you have a quantum system which creates space, that quantum system will have a metric, and that metric could have deformation. So you have metric, dimensionality, and deformation. The deformation is a natural event. Every time that you define space might not be uniform. In physics, unlike mathematics, in physics, space can have elasticity, and that's what makes mathematics or mathematicians handicapped when it comes to understand the universe. You mathematicians will never come up with elasticity; just is not part of their vocabulary. And so we have a metric fluctuation, initial metric fluctuation, and that metric fluctuation has a node which separates two regions. The outer region has contraction, and the inner region has dilation. So that's the topology that generates universes. Why is that? There is something called Prince-Rupert drop. Prince-Rupert drop, it happens when you pick up molten glass and you drop that molten glass on water. The tensions get frozen. The outside layer gets cooled first, and the inner layer later. And the end result of that, the outer layer has contraction, and the inner layer is trying to dilate. There's a tension there. And when you clip the glass, somehow scratch the glass, you have what's called is an entropic explosion. And that's what happens to the universe. When after the initial fluctuations, the outermost contraction layer and the innermost dilation layer were the only two layers left. And there was an option. They could recombine or not. If they recombine, there wouldn't be any matter in the universe, and the universe will just unravel. If they don't recombine, the inner dilation layer will push the outermost contraction layer, and the outermost contraction layer, or OCL, will fragment and expand at speed of light. And at that phase, I call it a black hole. Is a coin name for a black hole of a hyperspherical shell shape, as opposed to the garden variety black hole, which is spherical. So that's how the universe began. It began at zero temperature, at a smooth contraction layer, which has 0 internal degrees of freedom. So the initial state of the universe had entropy equal to 0, as it should be. You shouldn't start a universe with a big explosion. A big explosion is not 0 entropy. That goes against the laws of thermodynamics, and so it's wrong. It's wrong. The Big Bang it's bad. It's wrong in every aspect, and it's stupid. But so my universe starts as a 0 Kelvin black hole, and it expanded at speed of light, pushed by the inner dilation layer. All particles start to surf that inner dilation layer. They have a 3D volume. That 3D volume can be oriented with respect to the radial direction, which is the direction in 4D. So they can surf like the surfers in the pond, in the pond wave. So that's what happens. And of course, as they expand, the first thing that's going to happen is that they are going to convert past the transition from black hole to neutron star. The phase called neutron star, I called it neutronium. Again, is a hyperspherical shell-shaped neutron star. There is no word for that shape, for that kind of object, so I called it neutronium. And so when that happens, there is the introduction of a new degree of freedom. Before, when matter couldn't move inside the black hole, that phase I called flat hydrogen. Protons and electrons are still there. That's what we have inside a black hole. The only difference is that those protons and electrons, they don't have orbital degree of freedom. Once you pass the transition phase into neutronium, then neutrons starts existing. So you start having magnetic moment. You have a hypergeometric universe which now has is made of neutron matter, and has magnetic moment and has a orbital degree of freedom. At that point, the universe, the transition triggered 4D sound waves. Those sound waves, they are really happening within a 3D hypershell, but they can be only represented by a 4D base of wave functions. In 4D, you use something called hyperspherical harmonics. Hyperspherical harmonics is not your garden variety, it's spherical harmonics. Spherical harmonics are used to make any figure on the surface of a sphere. If you have any image on the surface of a sphere, you can decompose that image in spherical harmonics. That's what is done for the CMB. You decompose the image of the CMB, which is the image of around us of a sphere of 14.04 billion light years. So it's a very, very far away sphere, very large, and the CMB. And so you decompose, you get the you get the spherical harmonics spectral decomposition. Hyperspherical harmonics, which is what we use in 4 dimensions, is not the same or as the spherical harmonics, which means that one cannot, is not a complete base for describing what happens on the surface of an embedded sphere, on which is the surface of the CMB within a 4D hyperspherical shell, okay? So, which means that I had to move the observation point within the hyperspherical hypersurface until I found the location of Earth within the universe. So that's how I create the map of the universe. So I moved around our point of observation, carrying a spherical observation volume of the universe, and until I found the place. So that's the location of Earth, which I found on the map. At that point, I optimize the wave functions, the base set, until I got the 4D spectral decomposition or hyperspherical harmonics spectral decomposition of the CMB. That allowed me to create not only the density fluctuations on the surface of the observational volume, but also inside the observational volume. And so that's how I create the 3D map of the observable universe. It's more difficult than it looks. Because I had to understand how the CMB was modeled and all the details and so on and so forth. And not only that, but I had to understand all the math and the implementation of those decompositions, and I have to find out how to do optimal calculation of hyperspherical harmonics, which expand much faster than spherical harmonics. It has one more index, and so spherical harmonics has L and M. Hyperspherical harmonics has K, L, and M, and so on and so forth. So the number of base sets increase very much with K, very fast with K, okay? With the quantum number K, right? So as I mentioned, so this is a record. What I was talking about. So you start with an initial hyperspherical metric fluctuation, and after that you move into the black hole with the inner dilation layer pushing the outermost dilation contraction layer, our universe. The black hole becomes a neutronium, creates the hyperspherical harmonics, which I call neutronium acoustic oscillations, or NAO, which is a fun name. And after that, the neutronium continues expanding until it starts decaying, which means that the neutronium starts evaporating because the density went below a certain value. And when that happens, energy is finally released. The energy is 0.78 mega electron volts per neutron, and that's what heated up the universe and created the CMB, the plasma, the hot plasma. So I modeled everything and including the hot plasma. And the hot plasma is where you have what's called baryonic acoustic oscillation. So my theory adds one extra source of oscillations, which is the neutronium acoustic oscillations, which is triggered by the black holium neutronium phase transition. So here is the processes, black hole neutronium phase transition, neutronium acoustic oscillations, freezing of the neutronium acoustic oscillations. The freezing happens because the neutronium waves, the sound waves start oscillating, but the velocity of the sound waves, which is initially close to the speed of light, goes down very fast when the density reaches 300 mega electron volts per femtometer cube, which is an energy density, and that's calculated when by people who model neutron stars and so on and so forth. And so the evaporation happens at the end of the first day of existence of this universe and went through 3 days. So instead of having a big bang and talking about bullshitting about 10 to the minus 43 seconds and so on and so forth, the universe was cold for a whole day, was expanding. At the end of the day, neutronium starts melting, evaporating, and releasing energy. It releases hydrogen, releases electrons and neutrons. That's hydrogen. So I have the recipe for the creation of the universe without any need for any massless particles, Higgs mechanism for mass creation, and so on and so forth. And of course, I have all the modeling for everything afterwards. And so this is the take-home lesson. We live in a 4D space, but we are being dragged by the inner dilation layer, which is where our negative energy in the universe is located. The inner dilation layer is in close contact with us. We surf it, so it's within femtometer distance, Compton wavelengths of one hydrogen atom. So that's the take-home lesson. So what happens to the astronaut that falls into a black hole? You didn't see yet the derivation of the laws of nature. What happens when I derive the laws of nature? I realized that the forces between particles, between neutral particles or electrically charged particles, decays with velocity and goes to zero at speed of light. This means that the dynamics itself of particles stop at speed of light, and that's equivalent to freezing the astronaut. So what happens to the astronaut is that he falls, but he falls like an ice cube. Time dilation is actually the weakening of forces when the absolute velocity reaches the speed of light. So the astronaut dies in a fiery death, but he dies frozen as an ice cube. Not cold, but frozen. So that's what happens. So never mind trying to go into a black hole to live forever. That's not a good idea. And so that's it. Thank you for coming to my video. Feel free to ask questions. Bye bye.